So consider a sample program. I've written this sample program in a special language called Little Man Computer. This is a simplified version of assembly language or machine code. The Python version of the program on the left is also shown. So here we have an IMP command, which is the same as saying input. Okay, add 7 is the same as saying add 7. Out is the same as saying print. So these instructions are fairly simple. Input, IMP stands for input, add stands for add, out stands for output. Okay, so hopefully you'll be able to follow along the next section. Use that program to perform a fetch for real. Now initially, our program counter is going to point to the first instruction in our program. So our first instruction is this IMP command, and the address of it is 0. As you can see, inside the program counter, we have the value of 0. Now the first stage of the FD cycle is to copy the contents of the program counter into the memory address register, or to take the address pointed to by the program counter and put it into MAR. Remember that MAR's purpose is to store the address of the instruction we're about to fetch. At the moment, our IMP command is not in the CPU, it's in RAM only. Now, the program counter must always point to the next instruction, so we will add 1 to it. You can see that number has changed by 1. So our program counter is pointing at the next instruction, which is our add command, whilst our MAR is pointing at our 0 instruction, our first one, which is input. Now remember that our PC will always point to the next instruction we're going to fetch, whilst MAR points to the instruction we're about to fetch. The instruction itself has not been fetched yet. Once we have the MAR, the fetch occurs, and the data that was stored in that address is sent to the MDR. So as you can see, our MAR has the value of 0. At address 0, we have the command IMP. That command IMP, the instruction, is then sent down the bus all the way to the MDR inside the CPU, where it's stored. So we use the address of the MAR, which will go down the bus to RAM. It will then find the instruction at that address and send it back down the bus to the MDR where it's stored to be decoded and executed later. So the instruction can't be decoded and executed from the MDR. We have to introduce one last register, which is known as the current instruction register, or the CIR. The instruction is copied from the MDR into CIR, where it's decoded and then executed. Now, to complete the picture, you might be wondering, why do we have so many registers in the first place? Why can't we just simply get the instruction? Well, the reason is quite simple. We can actually execute one instruction while we're fetching the next. So this diagram is showing that. Notice that instruction 0 is in the CIR. It's been decoded and executed. However, notice in the MDR and the MAR, the values have now changed. What's happened is we've now done another fetch, or we're doing another fetch whilst the instruction is being executed. So MAR is now pointing at the second instruction, and the MDR has obviously had that instruction sent to the CPU. The program counter, because it always points to the next instruction, is now pointing to instruction 2. So you can see the arrows on the screen here, 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 and here are pointing at different values now. So CIR is pointing at one instruction, the MAR, MDR pointing at the next, and the program counter is pointing at the third. And this happens all the time. This actually helps speed up the processor dramatically, so it doesn't have to wait for each instruction to be individually fetched. There is a lot of detail in the FDE cycle. However, you're not expected to know it all in that amount of detail. What you are expected to know is what each register does. However, without context, without knowing how they work together, that can be quite difficult. Trying to remember anything abstract without context is always very tricky. So here's a summary of the FDE cycle to hopefully give you a bit more context about how the registers work together. So first of all, the probe counter, which stores the address of the next instruction, is copied to the MAR. The probe counter is then incremented by one instruction, so it points to the next. The data or instruction from the memory address inside the MAR is fetched from RAM into the MDR inside the CPU. The instruction from the MDR is then copied to the CIR, and finally, the instruction is decoded and executed from the CIR. As that instruction is decoded and executed, the next instruction will be fetched. There's a lot of content there, so it's now a good time to pause. You need to know the following. What is a memory address? What happens during the fetch? And also what happens during decode. It's very important to talk about the specific registers which get involved in each of those stages.